Hi, Physics students. This is Miss Claire, and again, welcome to our Math 6 class. We are now on Chapter 6, Multiplication and Division. In this video, you will learn three lessons. It talks about multiplying and dividing numbers by a one-digit and two-digit numbers, and also using multiples and factors. Okay, P6, are you ready to learn? Come on, let's get started. Let's start with lesson 1 or lesson A, multiplying numbers by a one-digit and two-digit numbers. So I have here a problem. Take a look here. I have here bottles. We have bottles with the capacity of 490 ml and big bottles with 1,580 ml of water. Now try to find the total capacity of the small bottles and the big bottles and share your answers during our class. Okay, let's move on. Okay, I have here a problem. How much do three similar computers cost? Okay, if a computer costs $1,125, how much do three similar computers cost? So we will multiply this by 3. I have here method 1. We simply use distributive law. So we have 3,300 plus 75. So the total is $3,375. Take a look here, children. 1,125 is close to 1,000. Multiplied by 3 is 3,000. So the product is about 3,000. It's correct, right? 3,375 is close to 3,000. We can also use another method like this. Simply multiplying each digit or each place value by 3 and still we can get the same answer, and that is $3,375. Another problem, take a look. How many dumplings can be made in 31 days? So this is multiplying a number by two-digit numbers. We can use method 1. This is by distributive property. We will break the 31 into 30 and 1. So we have 69,360 plus 2,312. So the total is 71,672. So this is the method 1 by breaking the number into tens and ones. Another is by multiplying the number by the ones first by 1, next by 30. So we still get the same number and the answer is 71,672. So there are 71,672 dumplings can be made in 31 days. So that's how to multiply numbers by a one-digit and a two-digit numbers. Now let's go to lesson 2 or lesson B, dividing or divide by a one-digit and a two-digit numbers. Okay, look at this ribbon. We have here a pink and yellow ribbon. Cut the pink ribbon into 7 equal pieces. How long is each piece? Write it as a mixed number. So how are we going to solve this one? Simply by dividing 100 by 7. Okay? And how about if we divide or cut the yellow ribbon into 12 equal pieces? Again, by dividing 100 by 12. So during our class, children, we will compute this and let's find the answer. And the answer will be in a mixed number. Okay, I have here another problem. How long will it take Amir to save up to buy the bicycle? The price of the bicycle is $497 and he saves $9 each day. So how long or how many days will it take him to save up to buy the bicycle? So we will divide 497 by 9. So this is the step 1. Divide the tens, 4 hundreds, and 9 tens is 49 tens. So we will divide, we get 5 tens. 5 tens times 9 is 45 tens. So we have a remainder of 4 tens. The next step is we will divide the ones. So we have 4 tens plus 7 ones. It becomes 47. We will bring down the 7 ones. So we have 47 divided by 9. We have 5 ones. 5 ones times 9 is 45 ones. So we have a remainder of 2. So our answer is 55 and 2 nines. The 2 here, children, is our remainder. And the 9 is the divisor, this one. And the 2 here. Okay. So the answer is 55. But when we take a look on our problem, the problem here is how many days for him to save so he can get the price or he can buy the bicycle, which is $497. If he will use 55 days, he can save only $495, and this is not enough to buy the bicycle. So we will add one more day, and that is 56. So 56 days, so he can get $504. It means he can buy this bicycle in 56 days. Okay, P6? Okay, another problem. What is the exact length of each piece of wire? So let's cut the 811 centimeter copper wire into 24 equal pieces. So this is dividing a number by a 2-digit number. Since this is a 2-digit number for our divisor, we will get 2-digit numbers also here. So 81 divided by 24 is 3. 3 times 24 is 72. Let's subtract. We get 9 as a remainder. We will bring down the 1. So we have 91. So this is 9 tenths and 1. So we have 91 divided by 24. We get 3 again. And 3 times 24 is 72. And our remainder is 19. 19 cannot be divided anymore by 24. This is our leftover. And this leftover becomes our numerator. The 24 here becomes our denominator. So each piece is 33 and 19 out of 24 centimeters long. So this quotient, this answer here is about 32 if we round up. Because 811 close to 800 and 24 is close to 25. 800 divided by 25 is 32. Okay, next. Let's go to lesson C using multiples and factors. Are you familiar with multiples and factors, children? Okay, stay tuned. So look at this bell. The bell in the tower rings every 2 hours. It first rings at 9 a.m. So what are the next 3 times the bell will ring? And how can you know if the bell will ring 31 hours after 9 a.m.? So let's share your answer during our class, children, and try to find the next 3 times that this bell will ring. And also, here, there is a second bell. It rings every 3 hours. It also first rings at 9 a.m. So what will be the next time that 2 bells will ring together? So there will be a time that both of these bell will ring together at the same time. So try to locate or try to find what time is that these 2 bell will ring together. Okay, I have here a problem. We have arranging markers and benches. Okay, a marker and a bench. This is a marker. This is a bench. Are placed at the start of a trail. Markers are placed every 4 meters. So we have 4, 8. The next is around here. That is 12 because every 4. Benches are placed every 10. So 10, 20, 30. And the next is, yes, 40. How far from the start of the trail will the marker and bench next please be placed together? So there is a time, there is a mark here that this marker and bench will be placed together. So how many meters is the is that from the trail? So let's going to solve it by this. We are going to find the multiples of 4. Remember, markers is 4 meters from the start. So 4, 8, 12, 16, 20, 24. Inches is by 10. So starting from the trail, from the start, 10, 20, 30, and 40. Have you noticed something? There are numbers that are common for the markers and bench, and that is 20. So, these 20 are what we call the common multiple of 4 and 10. A common multiple is a number that is multiple of 2 or more numbers. Therefore, the marker and bench will next be placed together at 20 meters from the start of the trail. It means that from the start of the trail, 20 meters, you can find the bench and the marker placed together. How about the next meters from the starting point? How many meters from it? So let's continue counting, finding the multiples of 4 and 10. So if we will continue the 4, we will get 24. The next is 28. Then we have 32. We have 36. And we have 40. So 40 children is also a multiple of 4. And as you can see, we have also 40 here. Therefore, we can still find marker and bench will be placed together at 40 meters from the start of the trail. So that is what we call common multiples. Okay, I have here another problem. Packing apples and lemons. Fiza wants to put 12 apples and 18 lemons as many bags as possible. So each bag must have the same number of apples and lemons. So how many bags will she need? Take a look here. 12, we can use one bag. In each bag, 12 apples. We can use two bags. In one bag, we can have 6. So times 6 is 12. We can also use 3 bags. So in one bag, there are 4 apples. For 18, we have one bag, 18 apples. 2 bags, we can have 9 lemons. 3 bags, we can have 6 lemons. So as you observe, 1, 2, 6, 6, and 3 are both can be found in 12 and 18. And that is what we call common factors. Okay? 1, 2, 3, and 6 are what we call common factors of 12 and 18. Therefore, the apples and lemons can be put into one bag. You can put it in 2 bags, you can put it in 3 bags, and you can put them in 6 bags. So a common factor is a number that is a factor of both or 2 or more numbers. So what is the most number of bags that we can put the apples and lemons? Yes, it's the 6 because this is the biggest factor for both 12 and 18. Okay, P6, I have here a problem for you. Jen has many cookies as tarts. She's packing them into boxes without any leftover. Each box has 5 cookies and 4 tarts. So what is the smallest number of each type of snack she can pack? Okay, do you understand the problem? So all you need to do is to find the smallest number of each type of snack she can pack. So each bag can have 5 cookies and 4 tarts. Okay, children, please answer this problem and write your answers in my question in Google Classroom. So that's all for lesson 1, 2, and 3 for chapter 6. I will discuss more about this lesson during our class. Thank you for watching P6 and I hope that you learned a lot in this video. Always remember to stay safe and healthy. God bless everyone and have a great day.